Today in this session, we will see in detail about state space search. So, which will be the one of the methodology for solving our problems. Before going in detail about problem solving methodology in artificial intelligence, we will see some aspects like functionalities which is available in artificial intelligence. So there are many things like problem solving, learning, reasoning, using experience, etc. Among that, we what we are going to learn is problem solving. So it is one of the topic that will be taken as an particular, subject in artificial intelligence problem solving methodology. So we'll see in detail about this problem solving. So while you are taking problem solving, what actually the problem is will be given a state, and from the given state you have to go to the desired state. For example, I can say you're being in a Chennai and you want to reach Delhi. So you'll be in Chennai. Chennai will be the given state, and the desired state will be like you need to be reaching the Delhi. So that will be the desired state. So how this will happen is depend upon the decision that we are going to make. From the given state, we need to take a decision in such a way that our decision make us to travel in to reach the Delhi. So that is the thing, like given state will be Chennai and the desired state will be Delhi, means we need to travel in north. If we travel south, we will be not reaching Delhi. So that is a decision that we have to make. So in what way we are going to reach the desired state. So this can be solved. The decision can be taken in two ways. So one is a knowledge. So knowledge based பண்ணி நம்ம decision எடுக்கலாம், and the other is called search. So in both ways we can take decision. So one is like knowledge and another is a search. So knowledge and search, this we can elaborate in this way. Like, what is knowledge? If you are given a Rubik cube in your hand, and if you are able to solve the Rubik cubes in say 10 minutes or 5 minutes using some approach or using some methodology that you learned, so that is the thing that we can say it as a knowledge. You have gained some knowledge to solve the Rubik cubes. So you will be able to solve the Rubik cubes in a given amount of time, say 5 minutes or 10 minutes, in a fixed amount of time, because you know how to solve the Rubik cubes, you know the methodology. So this type of solving a problem, see, we are seeing a problem solving methodology. Among that, knowledge comes first, where we know exactly how to solve that issue. In our case, I am taking a Rubik cubes, where you will be able to if you know the formula, if you know the strategy how to solve this Rubik cubes, you'll be solving it very easily. This type of solving the problem, we can say it is a knowledge based thing. Where opposite, like in, if you don't know how to solve this issue, if you don't know how to solve this Rubik cubes, what you'll do, you'll simply rotate the Rubik cubes in such a way that to find a solution. You don't know in the methodology, you will be taking an half an hour or 1 hour, even a day, a week. In that way, it will be gradually, it will be going depending upon the moves that you make. But definitely I can say you will be finding a solution not equal to that of a person who got the knowledge to solve this Rubik cubes. It will be somewhat like delay in timing. So it depends, like the search, this type of methodology to solve the problem is called as search. So it differs from knowledge. So we keep the problem solving as a base, and the problem solving means like we have a problem, we have to solve that. In this example, I can say that Rubik cubes is in your hand and you are going to solve the problem. So to solve this problem, you'll be having like knowledge based thing and search based thing. Knowledge means you know the methodology to solve the problem. Search means you don't know the methodology, you'll simply rotate the Rubik cubes and you'll be finding the solution. So this is no method known and method unknown. So that is the thing. So knowledge, if you consider knowledge, it can be divided into two types. One is a memory based thing, like you'll be having the memory, like previously you may have solved an issue or solved a problem, and that knowledge is stored in our memory, and using that memory knowledge we'll be solving the issue. And another thing is a rule based thing, like some people will derive an way to solve an issue, and they will formulate the things so that the other person can study that and they can prove that problems. So in this way, knowledge can be divided into two things, which is memory based and rule based. So here what we are going to see is the second criteria, which is called as search. So the searching, like what is, before going in detail, that is, I told you about the searching methodology. Searching is like you don't know the steps how we are going to solve an issue. So before going into the searching algorithm, you need to know in detail about the state search space. I mean, it is nothing but a space. Like you'll be given a point. For example, say Chennai, you need to travel to Delhi. What is the thing? How will you travel from Chennai to Delhi? So that is the thing. So initially you'll be starting from Chennai, and from there you have to reach small neighboring nodes. For example, Chennai to Bangalore, then to Mumbai. In that way, you will be reaching some interval nodes, and you will make to Delhi. So that is the thing. Like here in our example, you are given a cube that is shown in the first slide, as I described. You'll be rotating, like there are 6 possible rotation you can make in a dice to change the order. So I can put it in this way. So initial first stage I can say it as an yes, and from there I can put like this next state as A, B, C, D, E, F. So there are 6 possible moves from the starting node to find the solution. So this can be elaborated in detail in the next thing, where I can take a 8 square problem. So see, this is the initial state. So this is the initial state. This is like an 8 square problem. You are given a square like 8 squares where the numbers are given, and one of the square is left out. So you need to reach the goal state. See, this is the starting state, and G I represent as a goal state. The goal state will be like this. From the S state, I need to reach the goal state. How I will find the solution? That is a question here. So initial state is yes. So how I am going to move is from S state. See, there is one option like 1 minute. So this 3 can be moved here, or this 6 can be moved here, or this 1 can be moved here. In this way I can make a move from the starting state. So I have to decide which is the move I am going to make. So for example, in the here, second, from S I can move to A. You can see that the 1 is brought up. So this is one state, like from starting state I can move to the A state, where the 1 has been taken above, and the square below the 1 is left out. Similarly, from S I can take another 2 moves. I can bring 6 to the left or 3 to the down. So that I can put here as B, where 3 is brought down, and in the C you can see the 6 is taken to the left. So these are the possible move. Rather than this, like there is no other chances from S I can move directly to goal state. I need to move either to one of this node, whether like to A or B or C. This thing like A, B, C are called as like neighboring nodes. So the nodes that we can go to, we can travel to from S. From S we can travel either to A or B or C. Here we need to take a decision in such a way that which node will be correct for us, like which node will bring an output to us. Our output should be like we should reach the G state, which is like in the rightmost thing. So this will take some procedure or algorithm to solve that the type of problem. So here what I'm saying is, before going into an algorithm, like we are learning the basic concept of how to scratch an algorithm. So these are some steps, like from yes we can move to A, C, B or C. So these are the only 3 possible moves from the S state. So no other move is possible from this S state. So this thing is called as a space search. Like these are the states. From S we can move to A state or B state or C state. So these all states are called as a state space search. So these are the possible moves from initial state S. So I can draw this like yes, from yes I can move to A or B or C. So this is some like type of tree diagram, where usually like in the previous scenarios, like, while you are studying C++ or Java, you might have learned this tree structure. The only difference from that language to here is like there they will give the entire tree to traverse. Here the thing is you will not be given any tree. Here only the starting point will be given. We need to generate the tree and we need to find the solution for like what is the best solution, like how will we reach the goal state. That is the thing that we have to find ourselves. Only the starting node will be given, we need to generate the tree and we need to find the solution ourselves. Okay, similarly if from yes I'm taking the node A, you know that yes can be traveled to A, B or C. I'm just traveling and I'm exploring the tree. From A we can go to D. So see here what you can do is two moves are possible. In previous scenario, like yes we have three moves. From here like in A we have only two moves. Why two moves? Because there is only one square like left out, but there are only two possibilities because it is in the corner, leftmost corner. So either the one can be brought down or four can be brought left. That is the two moves that is possible. No other move is possible from the A state rather than moving from D or E. So I can draw like this. Like previous scenario we have drawn, like we have possibility of three moves. Now we can go from A to D or A to E. These are the two possible moves from A. And again if you are taking B as a starting node, from B there is only two possibilities. You can say like 3 can be brought up, I mean move to up, or 2 can be left, I mean move to left. That is a two possibilities move that we can make from the node B if you are chosen B as a path. So here like B can move to F where the 2 is taken to the left, or B can move to the H where 3 is taken to the up. So these are the two possible move from B. So this I can plot like this. Previously we have generated like S A B C, and from A we can move to D or E, and B you can move from F to H. So this is the diagram that we are generating. You can clearly see that this is a form of a tree which is being generated by us. From the starting state we have generated A B C. Like these are states. Like from S we can move to A state, and A you can move to D or E state. So these like we are exploring the state space. Like from one state we are moving to another state, so in order to reach the goal. If you reach the goal we can say that we found the solution. That is the thing we are been drawing here. So like last is like C option. You can see clearly like here there are four possibility move here. How 4 mean like 6 can be moved to the right, or 7 can be moved to the left, or 2 can be moved to the down, 4 can be moved to the up. So in that way there are four possible move in this C. So see here there are the four possible move I have generated here from this 8 square. C can move to I or J or K or L. These are the four possible moves that you can take from C. So I am exploring the state C, so that I am getting four possible moves here. This four possible moves are, we can say it as a state space, like neighboring nodes of C, and you can take a decision like from moving from C to any of the states. The decision may depend upon like goal. What is the goal that you have to reach, whether we are moving towards a goal. In that way we have to take a decision. So that we will see in detail in the next sessions. Here only the introduction is given related to the state space. Okay, so I have added the diagram. Like for C I can move from I, move to I, J, K or L. In this way I can move. So I have to decide correctly like what is the node I can move from, like starting node to which node I have to take a move. In that way we have to decide and we have to make a move. So these are the possible neighboring node from S, and ABC is a possible node, and from A you can go move to D or E. In that way we have all the possibility nodes for each and every nodes. The next session we will see in detail about the first basic algorithm, how to, like we are not going to write the entire program, how we are going to form an algorithm to reach the goal state. We'll go in basic way, like how to deal the from starting state, how we are going to move into the goal state. We'll go step by step, like from the algorithm, scratch starting algorithm to the maximum, like whatever the algorithm that is available at present we'll see one by one. Thank you.